trichloromethane, CHCl3. All right, the trick here is to look at the number of valence electrons for each of these molecules. Now, the valence electrons on carbon, let's start with that one first. One way to do it is basically you look at this periodic table, and if you're using the American way of going about looking at these things, you're going to have these numbers up here. And so this is 1 valence electron, 2, and then 3, 4, 5, 6, 7, 8. And then over here it gets all kinds of funky valence electrons. That would be in this area right here. But carbon right here is pretty nice because it has 4 valence electrons. And you're going to find that carbon bonds with a whole lot of things. So the way you do carbon is we can just do carbon and then go 1, 2, 3, 4, like that. And then the way we do chlorine, let's see, we'll do chlorine and go 1, 2, 3, 4, 5, 6, 7. And hydrogen is just 1. Let me just show you what that I know that chlorine is 7 because chlorine is in this group number right here. So when we bond these together, the first thing we're going to do is we're going to count up the number of valence electrons. So this guy has 4 and this guy has 7 of them, but there are 3 of these chlorine molecules, and this guy just has 1 of them. And there's just 1 hydrogen. Cool. So let's see, that would be 4 plus 21 plus 1, that would be 26. And since it has an even number, we're good to go here. We don't have any kind of funky things happening. And the one we're going to start off with is the carbon. We put that one in the middle because it has the most amount of unpaired electrons. It has 4 unpaired electrons, which kind of makes it really nice to, start combining things with it. Remember, the goal here is to actually make it so that way you have this extra floating electron paired up with this thing, because in essence this guy wants to have 8 on its outside, and right now what it has is 4 on its outside. So I'm going to tack on the hydrogen right here. And see, now this hydrogen and this carbon, basically they have this shared group right here. And that shared group is making that carbon happy and the hydrogen happy as well. So that's why they bond up together. Well, I've got my 3 chlorine atoms to tack on. So I'm going to put it like this. And then his extra dots right here. And then like this. And his extra dots right here. And then this one right here. And his extra dots right here. Now, what happens is in the Lewis dot structure, we can always say, well, since these guys are bonded, I'm going to draw this as a solid line. And then let me just make it a little bit prettier. So let me just find my eraser a little bit. Here we go. And I'll just make them horizontal and vertical lines because that just kind of makes things easier. Boom, 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 boom. And here, my friends, is the Lewis dot structure of the trichloromethane. If you saw another notation that I've seen before, and I don't know if your book does this, but I know that this is something I've seen people do, is those double dots right there. See these double dots on the outside right here? They just draw a line right there. I guess it's because they're too lazy to put 2 dots, which is fine. And then the hydrogen doesn't have any dots on the outside of it, so he doesn't get any extra. I've seen it done this way. I actually prefer it this way. You can do it either way. Let's try another one. Let's try sulfur dioxide. So that would be SO2. All right, sulfur is how many valence electrons? He's got 6 of them. So I'm going to draw it. 1, 2, 3, 4, 5, 6. And then dioxide is, well, oxygen is what was it? I forgot how many it has. That has 6 as well. Okay. So you got 1, 2, 3, 4, 5, 6. All right, now something kind of funky is happening here. Let me just check out what's going on. Let's see. I've got a case where, let's see. All right, let's count the number of valence electrons we have. This one has 6 of them, and this one has 6 of them, but there's 2 oxygen atoms because it's SO2. So that gives me 6, 12, 18. 18 valence electrons, which is good because it's an even number. Now, sulfur will be the central atom, basically because I'm going to surround it with those 2 oxygen atoms on the outside. Now, one of the things I could do is this. I could go, all right, sulfur, 1, 2, 3, 4, 5, 6, and I could have my oxygens. Oxygen, 1, 2, 3, 4, 5, 6. And my other oxygen, 1, 2, 3, 4, 5, 6. And then these guys will bond like that. But the problem is, I kind of have a problem, and it's that these extra electrons right here are not paired up with anything, and so that's not really how this thing is going to bond and form together. So I'm gonna have to get creative here. Let's try this. Sulfur, 1, 2, 3, 4, 5, 6. And I think what I'm gonna do is I'm gonna say, all right, well, what's going to happen is, let's see, my oxygen out here, 5, 6. I want him to create a double bond. Yeah, let's do that. So let's see, wait a second. All right, he's going to create, it makes no difference with oxygen. Okay, so let's see, he's going to create a double bond. So I'm going to have the oxygen with the 1, 2, 3, 4 and the sulfur, and he has a double bond. So that makes the oxygen happy because he has 1, 2, 3, 4, 5, 6 in here. This guy has 1, 2, 3, 4 and then 5, and I'm going to have that other oxygen out there, 1, 2, 3, 4, 5, 6 right here. And then what's going to happen is, I think this sulfur is going to donate to this oxygen right here, and so that makes this guy happy, and it makes this guy happy, and then it makes this guy happy. All right, I hope that makes sense.